Hello, this is Guard again. This is the simulation that I had that I showed that other picture of. This is what it looks like when it just starts out. So you can see, there you go. But I wanted to go over the code a little bit at least. So it's just, HTML here at the top, some CSS to make everything black background with white. We have a div at the top here for some stats from the quote player, which right now is just one of the planets, so I can look at specific stats on that. And then this bit here, debug for other stats, and then the canvas element, which is where all the stuff is drawn. JavaScript that does that stuff. Run speed, I put it in its own variable, so I can change it up top without having to find it, even though it's just down here in case the code gets bigger. I don't know, whatever. Anyhow, scale factor, that doesn't actually do anything yet. That's what I was about to start working on now, but I'm gonna look at this first. Drawing a path, yes or no, because as you can see right now, it draws a path of the objects instead of just the objects. I could turn that on and off. There's the player ID and the render ID. Player ID is just currently is just ones where the stats at the top of the page display when I have those stats going. Here, those ones up there. And the, let me put that back. Oh, that's not quite right. I'm sorry, yeah. And then render ID is something that I just added, which basically it allows you to focus on a particular object when it renders. So like right now, I'm going to turn off pathing and set this to 1. And if I save that and I refresh the page, first you'll notice that they aren't drawing paths anymore. Second, you'll notice that everything appears to be following this object, but what it actually is that we're staring at this object from this object's perspective. Everything else is going around, how it is. And so if you look closely, you can see that everything is still orbiting the sun the way it's supposed to. It's just our reference frame is a planet, so it looks like everything's orbiting us, which I thought was pretty cool, because that kind of explains how come, like, how people used to think that what do you call it, the universe, like everything revolved around us, and this kind of shows, like, at least in my opinion, it shows why people could think that, because if you look, everything looks like it's going around us. It looks like it's going around us in a very, very crazy, incorrect pattern, but I think that's pretty cool. I'm going to change that back to what it was. Let's see. Okay, so initialize. I put it in its own function, the system that we draw here, stably system, because I'm going to be adding more things, but I kind of want to keep this one because I kind of like it. Let's see, where was I? Alright, and then set interval, loop, run speed. Yeah, so that loops it. Here's the loop. First we do the gravity function on each object, and then update, which gravity simulates gravitational changes in velocity. Update actually moves every object by its velocity, and then checks for collisions, except not yet because I haven't done the collisions code yet. Then we have redraw, which draws the stuff onto the screen. Debug output, the player output. So this one would be the bottom of the screen text, this one would be the top of the screen text. Function thing, this is a constructor. This creates the objects in the array. There's the mass, the radius, which is square root of the mass divided by 2. Later on I will change that, but for now you can manually change that if you want, or whatever. Also, it has a lower limit of 1, so everything will at least be visible. The smallest objects are all the same size there. Location, velocity, rotation I haven't added yet, but I just commented it there because I wanted to remember that. Fill color, so that it draws in the different colors, and then whether it's fixed in place or not. In my example so far, the sun has always been fixed in place. Okay, the gravity function. It steps through all the objects, and remember that because it's like a function of the constructor. I don't quite know how to explain this well, but because of that, we have an object that we're focused on, then we're stepping through all the other objects. So first of all, if it's fixed, we don't do anything because, we don't want to do anything. If we're comparing our object to ourself, well, first of all, we'll get 0 for all our values, which will cause a divide by 0 error, so that's bad. But also, an object doesn't have gravitational influence on itself. Let's see. Okay, so these variables, they're booleans for whether the x or y axis was negative. And the reason we have that is if you look here, this x minus object's x. Basically, the object we're calculating forces on, we subtract the x value of the other one, and same for y, to get the relative distance. And hold on, I'm gonna make that more specific in the comment. Yeah, whatever. And then if we have a negative, that will screw up our calculations. So we have this flag to remember that we had a negative, and we flip it to a positive. Then we go down here, gravitational acceleration equals 10, that's the gravitational constant we're using, which is way off, by the way, times objects dot m, trying to remember, oh yeah, object's mass, so the mass of the object we're calculating the influence for, divided by distance squared. So distance squared is like if you think about it like a triangle, Pythagorean theorem, a squared plus b squared equals c squared. Right now, this whole thing needs to be c squared. So c squared is equal to a squared plus b squared, which is x squared plus y squared. So you see x times x plus y times y. And then we solve for the acceleration of x, and the way I do this, I have trouble explaining how I get this calculation here, but so I'm just gonna say what I did was I took the x distance divided by the y distance equals the x velocity divided by the y velocity, and then I did math stuff to come up with this equation, which will tell us the acceleration of x without having to know the acceleration of y, because otherwise you'd get the distance of y times the distance of x. I mean, the distance of y times the acceleration of x equals the acceleration of y times the distance of x, and you can't solve for that when you don't know both of them, because we're trying to solve for one of them, because we can't solve for both at once, because code doesn't work like that. Anyhow, distance of x times the gravitational acceleration divided by x plus y, which is, I'll have to go into more depth about how I did that if anyone cares to know. Then we have the gravitational force, and we subtract ax, which we just calculated, the acceleration of x. And I could have done this same equation just with the dx here being replaced with dy, but I noticed when doing some testing that because they were calculated separately, and because there are minor floating point errors in calculations in computers, that you'd either lose like a tiniest fraction of velocity or gain the tiniest fraction of velocity. So this way, even if the calculation is slightly wrong, it's at least kind of consistent within itself that the total acceleration is correct. Like this equation is accurate even if this one isn't 100%. Like, I don't know, it's hard to explain and doesn't quite make sense. Then we fix the negative values, so if we had a negative x, we set it back to negative. If we had a negative y, we set it back to negative. Except that's not how it works, because if you just had the acceleration of a object that was in a negative distance, negative acceleration, then it would just go farther away from the object. Same thing for positive. If you have a positive value and a positive acceleration, then you're going away from the object. So we fix the anti-gravity. We invert everything again, and then I then commit a programming, however you say that word, the one that's spelled this, since you can see my screen, foxpa, I don't know, whatever you say that, fake, you know what, shut up me. You apply the change of velocity to the velocity variable. You don't actually move the object though, because if you moved the object here, then the object would move in between calculating the acceleration on that object for everything else. So that's not how gravity works. Everything affects it all at once, so you can't move it here. So then we go down to the movement, which is conveniently labeled as such, which is just, you know, adding the x and y values with the velocity of x and velocity of y, which again, you're not supposed to, like the way you're supposed to write code like this is this dot y plus equals this dot vy. You're not really, you know, which is more concise and I guess a little more obvious what you're doing. Sometimes it seems like it's more obvious to me, other times it doesn't. Sorry, I had to scroll up to check something. Then we have the collider, which this is, as you might have noticed, part of it is commented out. That's because it's not actually a collider yet. I need to code that. I just haven't gotten to it yet. But how it would work is it would step through all the objects, and unless it's the same object as what you're comparing against, it would calculate, like, first of all, are you colliding, which would be an if, and if you are, then it would do stuff. This commented out if right here, basically, if the distance of this object minus the if the absolute distance of the two objects, which you get by subtracting the two, if the distance between them is less than the radius of the two objects in the x-axis, and the distance on the y-axis is less than the radius on the y-axis, then you would get a collision, which would be a box shape, which these are spheres, so a box-shaped collision is wrong. It's also extremely undesirable, especially if you have an extremely eccentric orbit that goes really low, because it would mean that it would trigger a collision instead of just, you know, orbiting extremely closely. So that's bad. That's what I'm going to work on next and fix. I also just now, while recording, thought there might be a problem with this calculation, because if you're using negative values, but the negative value is higher than, like, basically you need to have absolute values here instead of just so this is wrong. This dot x minus objects I dot x, or objects of I dot x, that is wrong, because you actually need the absolute value of that, because else anytime you get a negative value, which basically means a negative value is on the left of the object or the top of the object, and a positive value is on the bottom or the right, depending on whether you're looking at x or y. So a negative value would always collide even though it's not actually negative. Basically, an object that, wow, that looks crazy. That looks pretty cool. An object that is in the top left quadrant would always collide. Like, an object that was anywhere relative to your object, then the bottom right would collide, which is just wrong. Anyhow, then we have get velocity, which just returns the velocity of the object by adding the absolute value of both velocities. Data out is all this data here at the bottom of the page that you can't see because I can't scroll that far. Hold on, let me, darn it. Here, this should, there you go, now you can see it. All of that data is created in rows. You see the little bit of HTML formatting there is created in rows here and outputted. Then we have the draw function. And the draw function, first of all, we check if we're pathing or not. If we aren't pathing, we clear the canvas. If we are pathing, it ignores this. We step through all the objects and we begin path, because that's how you start a new object, else it does this really strange, actually, here, let me just comment that out real fast and save it and show what happens if that's off. Actually looks pretty cool. Ridiculous as heck, but it looks kind of cool. Basically, because we don't tell it to begin path in between drawing each object, it's drawing all objects with a line going to the center of the screen. So, or not even the center of the screen. I don't know. I actually don't know exactly what causes this to happen this way, but basically, as you can see, the screen gets cluttered up with extra lines that we don't want. So, best to leave that in there. all this commented out stuff was me figuring out how to make this next line. This next line was originally just the object's x value, the object's y value, and then when you scroll over, the radius of the object, and then start at 0, because it's drawing an arc, start at 0 and then go to 2 times pi, which would make a full circle. False is simply saying don't draw it counterclockwise. It doesn't really make a difference though, since we're drawing a complete circle, or at least I wouldn't think it would. But so what I changed it to though, basically this change is so that you can have the whole render ID and it renders from the perspective of a particular object. And to get that, I'm just going to basically read through my comments real fast and re-figure out how I did it. So basically, I thought to myself, we have x and y of objects, and we're going to assume it's 0, 0 for right now to try and figure this out. That's why I did that. There's a screen of this size, and we need to draw to the center. We have a focused object, which, well, I wasn't sure what I was going to use for the focused object yet. So I used player ID to start, and then I replaced it with render ID to separate the two so that I could have a reference frame without having to change what values were displayed at the top of the screen. And then let's pretend for the moment that the object we want to focus on is the object being drawn. That's the thing to keep it simple for me to figure out how to do it, because else I could get confused with myself. I then went objects plus the client width divided by 2. So if the object was at 0, then it would add the canvas, half of the canvas width, so it would display in the center of the screen. And then, as you can see in the comment over here, which only works for something at 0, 0. So that's wrong. Then I thought, okay, so canvas client width 2, well, now anything is drawn at the center. And then I finally figured it out that I basically need to take the object I'm going to draw, subtract the object that is the render ID. I know it says player ID in the comment, but that was me figuring it out. Subtract the ID of what we're focused on, and then add back the distance to halfway through the screen. So better stated here. Take our x, subtract where we are focused from it, add the length to reach the center of the screen. So that's what all that commenting is, and now that I've explained it, and I thought it'd be interesting to explain how my brain worked there. Don't know if it was or not. Hopefully it was. If you're watching, it was. Anyhow, there we go. Got rid of that. Don't need that anymore. I also don't need that line anymore, so let's get rid of that. Player out. Oh yes, this is a complete table of the data at the top, which goes into the player stats div tag. The debug out is a similar thing, except it steps through all the objects and gets the data for them and puts it in the debug div. And then we have the stably system, which is the what I've been using, and it's defined by these. It used to be defined by client width and height, but since I fixed that to not be necessary, it now draws everything centered at the origin. Well, actually, not at the origin, because then they'd all be in the same place. But everything starts at a different x value, but the same y value, since they're all, that's just how it was. That's how it ended up. And you see, this is how you change values after they've been set by the constructor. Is you just go objects dot and then the variable and change it. So you can see this one was changed to fixed true. This one was made yellow, green. This code, which means gray, or at least a particular shade of gray, which I very much like as a gray. I know there's a technically more gray color, but this one has just a bit of blue to it that I don't know, I like it. I know that's very strange. Oh yeah, and this is me reminding myself how to use the thing constructor, because I'm going to add another system now, a much more massive system, because I am currently about to work on the rendering code right here. I'm going to change it to where it multiplies by the scale factor, which I put up here. So yeah, this is entirely how this works. Where was I? I was right here. This is currently saved. I have some extra white space at the bottom here that I added so that I could scroll properly without having to move the box that I'm recording with on the screen. Not that you care, but let's go back to this. Oh, that's still rendering badly, so let's refresh the page if my mouse button will work. Uh-oh. I think I broke Firefox. There we go. Now it's working. It took a minute to load because it was having issues simulating all that at once. I actually have the same simulation running in 3 windows right now. I actually have a simulation running from that I started last night and has been going since last night. It's still going. Let me go grab that real fast and see if I can move it over here. Here we go. This has been running since last night. So let me bring this window down just a bit so you can see that better. So as you can see, the planet that is green is in a stable orbit, however is also in a it slowly, you know, goes lower in its orbit, goes higher. In fact, I don't know if it's in an extremely eccentric orbit right now or not. Like, it could be an extremely eccentric orbit or not. Then we have this asteroid in the middle, which is all this gray, webby, swirly stuff, which is in a very stable pattern for quite a while before it finally gets enough of a kick to go out into the outer system, and it gets interfered with by the red planet and thrown out of the system. The blue moon that was around the outer system has the same issue. It eventually gets perturbed enough by the stuff in the center to get kicked out of the system. And it's also, there's a particular word I'm looking for here, I think. Oh yes, I wanted to mention that I thought it was interesting that the eccentricity of the red, what do you call it? The red planet, basically, it may look like it's on a different orbit or that it's getting closer in, but if you look at the paths drawn by the blue line that are still there, it's not actually getting closer per se, it's getting into a more eccentric orbit. It's slightly shifted to the right a bit, more so than it's being, you know, that, yeah. Also, another interesting thing to note, if you look at some of these paths on the blue, they look very strange. They kind of go out here, stop, and then go back, and well, that's just the way it looks from this reference frame from it orbiting the red one. In fact, I didn't think about it until just now, but I'd love to see this simulation from the reference frame of the red object, which is objects 3. So I'm going to go set our render ID to 3, save this, go here, not that one, because that's the simulation I don't want to stop. Here's the one that I just started. Okay, I'm going to refresh it, and now we're going to see everything from the perspective of the red planet. So you can see the blue planet is in or the blue moon, I should say, is in a fairly stable orbit. However, it gets slowly perturbed by influences from the other objects in the system. And so you can see right now it's kind of making its way around the planet, the orbit, you know, changing a little bit each time. And I don't know if you feel like waiting long enough to see what happens eventually when it gets kicked out. I know I kind of don't. I mean, I kind of do, but kind of don't. I kind of want to just leave this running and look at the result more than sit here and watch it happen. Although I do want to show that I love the way the render looks from this perspective. I love how the way the planets and star and everything, the way it all appears to move when you change the reference frame is just very cool. I don't know if you'll agree with me on that or not, but I think it's very cool. The only thing that appears to orbit properly is the thing you're orbiting, but everything else kind of goes every which way. This is also, right here is a good example of why I really want to add rescale to this right now, because as you can see, this is at a like a how do I say this? It's, you know, it's not at a good what do you call it? You get what I'm sorry, I'm bad with words right now, but you can't see all the orbits happening. You just see parts of it as it comes in and out of focus. But you can see this moon is actually very stable for quite a while before it gets kicked out. The asteroid is actually much more stable, as you can see here. I don't know how well, basically, look at how dense this ring of gray is. Like, there were so many orbits there before it got kicked out. Whereas the blue, it does a lot of orbits too, but there's not nearly as much blue. And you might be thinking, oh, well, it's just covered up by the red. No, it's not. There really isn't that much blue. The blue gets kicked out much sooner than the gray does. And, but yeah, there we go. This is longer than I thought it was going to be, but I hope someone enjoyed watching this, someone got this far. Thanks for watching, etc., etc. See you in Gravity Sim. I need a name for this, don't I?